All right, let's dive into this paper. R1-Searcher, Incentivizing the Search Capability in LLMs via Reinforcement Learning. This paper is super interesting. It's about making LLMs better at searching.
Yeah, it's really cool. They're trying to solve this problem where, LLMs are amazing, but sometimes they just hallucinate facts.
Right, like their internal knowledge is amazing, but it's limited.
Exactly. So these researchers were like, hey, how can we make them actually use external search engines to get better, more up-to-date info?
That is a huge question because so much of the stuff online is constantly changing. Like, how could you possibly expect an LLM to keep up with all of it?
Well, that's what they're trying to figure out, right? And the results are pretty impressive. I mean, they've got some really interesting findings in this paper.
Yeah, we've got excerpts from the paper here. We're going to break it down for you. So first, let's talk about the problem. Like, why is this even an issue? Why can't LLMs just, figure things out on their own?
So the thing is, LLMs are great at generating text based on what they've been trained on. But when you ask them questions that need external knowledge, like really specific stuff or something that happened yesterday, they struggle.
Okay, so if I ask it about the weather in my specific town right now, it's not going to be able to tell me.
Probably not accurately. It might give you a generic answer, but it won't be able to pull in real-time data from a weather website, for example. Or if you ask it about something that's in your personal files, it can't access that either.
That makes total sense. So basically, it's limited to the data that it's already been trained on, which makes sense, but also is a huge limitation.
Yeah, huge limitation. And that's what makes this paper so cool. They call this limitation deliberative reasoning, which I think is a really cool term.
Deliberative reasoning. I like that. So how do they address this problem? What's this R1-Searcher all about?
So R1-Searcher is their framework for making LLMs better at using external search engines. It uses something called reinforcement learning, or RL for short.
Oh, RL. I've heard of that. That's like how they train those AI agents to play games, right? Like AlphaGo and all that stuff.
Exactly. It's about giving the AI rewards for doing the right thing and penalties for doing the wrong thing. So in this case, they're rewarding the LLM for using search engines effectively.
Okay, so instead of teaching it to win a game, they're teaching it to be a super searcher. Makes sense.
Yeah. And it's not just about typing in a search query. It's about understanding the results, picking the right information, and then integrating that into its response.
Whoa, that's pretty complex.
Yeah.
So how did they actually train it to do all that? Like, what did the training process look like?
So they took a really interesting two-stage approach. The first stage was all about getting the LLM to actually use the search engine, like not even worrying about correct answers yet, just getting it comfortable with the whole process.
So kind of like teaching a kid how to use a computer before you teach them how to code.
That's a great analogy. And then in the second stage, they started focusing on accuracy. So now the LLM is being rewarded for using the search engine to find the right answer.
Ah, so stage one is like learn how to search. Stage two is learn how to search well.
You got it. And to make all this work, they had to get really creative with the training data and the reward structure. They even had to modify how RL usually works because now you've got this external search engine involved.
It's wild. It's like you're teaching an LLM to think differently. Like pause, go search, then come back and finish your thought.
Yeah, exactly. It's really cool how they had to adjust things to account for that. And the results are pretty wild.
All right, I am dying to hear about the results now.
Okay, so get this. R1-Searcher actually outperformed a bunch of other models on standard benchmarks, even models using GPT-4o Mini, which is a really powerful LLM.
Wow, so it's not just a cool idea, it actually works, like measurably better.
Significantly better. And what's even cooler is that they didn't use instruction fine-tuning, which is where you give the LLM hints or pre-programmed strategies. They literally taught it how to search from scratch.
That's insane.
Yeah.
That means it actually learned how to do it, like it wasn't just following a pre-written script.
Right. That's the really exciting part. It shows that RL can be used to unlock these really powerful capabilities in LLMs. And they didn't stop there.
Oh, there's more. Lay it on me.
They also wanted to see how well it could generalize, meaning can it handle questions it's never seen before, not just the stuff it was trained on.
That's the real test, right? Because the internet is full of surprises. You never know what kind of questions people are going to ask.
Right, and guess what? It actually did really well on new data sets like music and Bamboogle. It even did well on online search using the actual Google API.
Whoa, so it was actually searching the real internet, not just a curated data set.
Yep, the real deal. And it beat a 32 billion parameter model that already had online search built in.
That is mind-blowing.
I know, right? It's like this relatively small model, trained from scratch, was able to outperform a giant model designed specifically for search.
All right, I am officially impressed. This R1-Searcher is seriously cool.
It's a game changer, and it raises all sorts of questions about what else we can do with RL and LLMs.
Like, what other skills can we teach and what other limitations can we overcome? This is just the beginning.
It's so exciting.
No. All right, we've covered a lot of ground, but we're just getting started. So we've talked about how cool R1-Searcher is,
Right.
But I'm really curious about the details. Like, how did they actually train this thing? The paper mentions a bunch of different RL algorithms like GRPO and Reunforce++, which don't rely on a critic model. Did they find anything interesting about these algorithms when it comes to Retrieval-Augmented Generation?
Oh, yeah, absolutely. So they trained a Llama 3.18b instruct model on a mix of Hotpot QA and 2 wiki datasets using both GRPO and Reunforce++ lay. Now, during training, both algorithms performed pretty similarly in terms of rewards, but GRPO was interesting because it generated longer text and attempted to retrieve information more frequently.
So it's like GRPO is encouraging the model to be more talkative and more reliant on external search. Did that lead to better performance on the benchmarks, though?
Well, it's a bit of a trade-off. GRPO did show better results on the out-of-domain dataset Bamboogle, which suggests it generalizes better, but on the in-domain datasets like Hotpot QA and 2wiki Reunforce++ actually did slightly better.
So maybe GRPO is more adventurous, while Reunforce++ is more focused on mastering the specific tasks it was trained on. It's kind of like the classic debate of breadth versus depth of knowledge, right?
Yeah, that's a great way to put it. And speaking of classic debates, the paper also tackles the age-old question of reinforcement learning versus supervised fine-tuning, or SFT. Did they discover anything groundbreaking there?
Well, I wouldn't say groundbreaking, but it's always good to have more evidence, right? What did they find?
So their findings actually supported what we already know. RL consistently outperformed SFT on both in-domain and out-of-domain datasets. It shows that RL, with its emphasis on exploration and learning from mistakes, is just better suited for teaching an LLM how to search effectively.
It makes sense, though, right?
Right.
RL forces the model to be more dynamic and adaptable. It's not just following instructions, it's learning how to learn. But I'm sure the details are pretty complex. What about the reward structure? That's a crucial part of any RL system. What did they find out about optimizing the answer reward?
So they actually experimented with 3 different metrics for the answer reward: exact match, EM, cover exact match, CEM, and the F1 score. Unsurprisingly, EM, which requires a perfect match, resulted in shorter responses during training and poorer overall performance.
Because it's just too strict, right?
Yeah.
It punishes the model for even tiny discrepancies.
Exactly. And while CEM offered some more flexibility, it was the F1 score that really stole the show. The F1 score considers both precision and recall, so it encourages the model to generate longer, more detailed responses, which ultimately led to much better accuracy.
So the F1 score strikes a better balance. It's not too strict, but it's not too lenient either. What about the format reward, though? What was that all about?
The format reward. That's a really clever mechanism to prevent the model from cheating or taking shortcuts. You see, without strict format constraints, the model might try to just generate its own documents without actually using the search engine, or it might produce output that's just nonsensical and doesn't follow the specified format.
So the format reward keeps the model honest. It forces it to play by the rules and produce responses that are coherent and well-structured. It's like a safeguard against laziness or cleverness that doesn't actually help.
Exactly. It ensures that the model is actually using the search engine as intended. Now, speaking of rules and structures, the training data itself is a critical factor, right? Did the researchers find anything interesting about the datasets and difficulty levels they used?
One thing that stood out to me was that they found it's important to challenge the model with difficult questions during training. When they trained it only on medium difficulty questions, it actually performed worse on the benchmarks compared to when it was trained on a mix of medium and hard questions.
That's right. It seems counterintuitive, but it makes sense when you think about it. The model needs to be pushed outside of its comfort zone to really develop its reasoning skills. It's like a weightlifter who only lifts light weights. They're not going to get stronger that way.
Exactly. They need to push their limits. And they also found that training on a diverse data set, like combining Hotpot QA and 2wiki multi-hop QA, yielded better results than training on either one alone.
That's another great point. It's about giving the model a well-rounded education. Expose it to different types of questions, different information sources. Prepare it for the real world, where things are messy and unpredictable. Speaking of the real world, let's come back to R1-Searcher's ability to generalize to online search using the Google API.
Oh yeah, that was super impressive.
How?
It was able to search the actual internet and find relevant information, even though it was trained on a static data set like Wikipedia. Why is that such a big deal?
Because the real world is dynamic. The internet is constantly changing. New information is being added every second. For an LLM searcher to be truly useful, it needs to be able to adapt to this constantly evolving environment. Remember, the model was only trained on Wikipedia, which is a snapshot of information at a certain point in time. But the real world is not like that.
Right, so it's not enough to just memorize facts. The LLM needs to be able to learn and adapt on the fly. And it seems like R1-Searcher is really good at that. It aced the Bamboozle dataset, which is specifically designed to test online search capabilities, and it even outperformed a much larger model called Search O1, which already had online search features built in. Amazing.
It really is. It's a testament to the power of RL and how effective the R1-Searcher framework is. We're starting to see the potential for this technology to revolutionize how we access and process information. But before we get ahead of ourselves, let's take a closer look at the case studies in the paper. They provide a lot of great insights into how R1-Searcher actually works in practice, right?
Yeah, the case studies are fascinating. They're like little windows into the inner workings of the different approaches. For example, when they compared the RL-trained models to the SFT-trained models, it became clear that RL encourages a more discerning approach to retrieval. The RL models were more likely to acknowledge when they didn't know something and actively seek out external information. The SFT models, on the other hand, sometimes relied too much on their internal knowledge even when it was wrong. It's like the RL models are more humble. They're not afraid to admit when they don't know something and ask for help.
That's a great way to put it. Humility in an AI now. That's something I never thought I'd say. But yeah, you're absolutely right. The case studies also highlight some really interesting differences in how different LLMs reason. For example, when they compared Qwen and Llama models, both trained with RL, they found that Qwen was incredibly good at decomposing complex questions into smaller, more manageable subproblems.
So like Qwen is a strategic thinker, breaking down a big problem into bite-sized pieces.
Exactly. And this just shows that the architecture of the LLM itself matters a lot when it comes to using search effectively. It's not just about teaching any LLM to search. It's about finding the right LLM for the job and training it in a way that plays to its strengths.
It's like building a team. You need the right people with the right skills for the task at hand.
That's a perfect analogy. And as we wrap up our deep dive into R1-Searcher, it's clear that this research has opened up a ton of possibilities. Imagine LLMs that can access and process information from the real world seamlessly. Think about how that could help us solve complex problems, make better decisions, even lead to new discoveries.
It's mind-blowing. It's like having a super-powered research assistant that can access all of human knowledge and help us make sense of it all.
And it's not just about research either. Imagine LLMs that can help us with everyday tasks like planning a trip, writing a report, or even learning a new skill.
It sounds like science fiction, but with research like R1-Searcher, it's starting to feel like a real possibility.
It is a really exciting time to be working in AI, but of course we need to be mindful of the potential downsides too. As LLMs become more powerful, we need to make sure they're used responsibly and ethically.
That's so important. We need to be aware of potential biases, privacy concerns, and the unintended consequences of deploying powerful AI systems in the real world. It's a conversation we need to keep having as we continue to push the boundaries of AI.
Absolutely. But for now, let's celebrate the ingenuity of R1-Searcher and the amazing possibilities it offers. A future where LLMs and search engines work together to empower human understanding. It's really quite inspiring.
It is. Well, that wraps up our deep dive into R1-Searcher. We hope you enjoyed this exploration and learned something new. Stay curious, and we'll catch you in the next episode.